Happy New Year, folks, and welcome back to the Practical Microservices stream. Hopefully, I didn't leave that countdown sitting on live now for too long. Pardon me. Still not completely over whatever it is I had, which is fantastic. It's just the way I like it. Let's see, connecting to the chat room here just to make sure I don't miss any messages. Let's see, what's up? So, New Year, exciting. What will change on this stream? Probably not a whole lot. It's about getting deep into actually building things. That's what we're after with this stream here. In addition to that, there is the let me pull it up here again because I can. So let's grab a trusty browser here. If you go to practicalmicroservices.com, I've got many articles now. I write a little short thing daily. This stuff is more targeted towards engineering leadership. So if you're a manager, an architect, VP of engineering, CTO, or something like that, you're who I'm trying to reach with this to help you get flow going in your organizations. The stream and then the YouTube channel are more about because like microservices fit into a greater whole. We're trying to make it so that we can take work from inception to deployed to customers quickly, and microservices are the architectural component of that, so that your code base isn't what's preventing you from doing that. That's typically not the first thing. Like when an org realizes, hey, we're not shipping as fast as we used to or as fast as we would like to, it's usually not the architecture that is the constraint in that flow. At least not at first. There's some work you can do to identify what that constraint is through methods that Lean will teach you or that Goldrat's theory of constraints will teach you. If you've addressed all those, there will come the time when it is the architecture that is your constraint in shipping more and shipping higher quality work, but that's typically not the first thing. Anyway, the mailing list is about that overall effort of trying to get flow established at an organization, whereas the stream, and at least for now, the YouTube channel is going to be focused much more on the technical aspects and the architecture itself. So that's that. And of course, there's always the book Practical Microservices. If you would like to have a hands-on walkthrough that you can do at your own pace, that book is there for that. It's written in JavaScript, of course. That's what we've been doing on the stream, is converting all of its code over to Ruby-based Eventide. Aside from the meetup stuff, which we're actually continuing today, but that is the kind of the main story arc for what we're doing. What will we do after that? There are some design flaws in the system in Practical Microservices, some mistakes that I made, and I want to correct those. And so that's what we'll do once we have the code ported over to Eventide. We're going to go back and fix those things and make them better. So let's see here. We were working on the composite component and the device video component and took some notes here. So I'm just going to read those real quick. So going through concurrency issue, triggered the error, spent the rest of the stream talking through a potential solution. I think we got something. We'll pursue it further tomorrow. I really should have put tomorrow in quotation notes or marks rather, because that was December 21st and today's January 3rd. And so this is when we are addressing it. So yay for being on top of that, I suppose. Sorry, browser is acting a little strange. Do I have two browsers open? I do not. Okay, I don't know what to do. Okay, anyway, here we go. So question is, did I make a drawing of it? Somewhere I took a note of what this other solution might be. And I have a feeling we're going to do more visual things today. So let me get my mouse rather than the trackpad. So did we take any notes? No, where would they be? Somewhere in the code? I was sketching this somewhere, I swear. Don't remember where though. Well, that's unfortunate. Have to go for memory. So let me use some text first. Huh. I thought I wrote that down somewhere. I didn't. All right. So let's see. What we were looking at, the problem was because, and I'm going to do this talk through to get my head back in the game here, but it was in this scenario here. So one composite request comes in and requests the video, and then the consumer for this requested event picks it up and sends it to the handler. The handler starts working on it, and that's where the most time-consuming portion of these flows occurs, where it's actually fetching the device, or sorry, fetching the video from the remote IoT device that is connected over a cellular network. Now, our cellular network, of course, is just this method right here with a sleep 30 in it, so that will take a good long time. But while that is being fetched, a request for another video comes in. And when it comes in, it's going to trigger writing a requested event here, which means that at the time that this handler started, it would have projected the device video entity and got the version of the entity that's currently there. And then something else comes in and writes to that stream. So when it has finished fetching, it will go to write the fetched event, having used the previously projected expected version, and then fail with an expected version error, because suppose this was the first event in that stream, which is what in these streams requested will be typically the first event. It will be writing with an expected version of 1 right here, but since another event was put in, the stream is now currently at version 2, and so we get that expected version error. So what's the problem? Well, then it crashes and restarts, refetches the video, and assuming more requests didn't come in the meantime, it would then work. So it's not like the whole thing's broken, but it doesn't feel correct either. We'll have wasted effort, wasted trips to the devices to get the videos, and things will go slower than we would want them to. And so there were a few different strategies for fixing that we were working through, and I really wish. All right, possible solutions. Here we are. One was to use infrastructure to save the file to the local file system and persist it across restarts. Though we are not deploying any of the components we've done on the stream, maybe we'll do that at some point in the future. If we were building like things meant for production, we would do that. And I think that would be really interesting to work through, getting it into whatever case may be. But I do kind of write them anticipating that if they were deployed, we would deploy them in Docker containers, not because you need Docker containers for microservices by any stretch of the imagination. It's like, if Docker makes sense for you, use it. If it doesn't, don't. At the end of the day, these are just Ruby programs that run, so whatever. But imagining them as Docker components, the file system is transient, ephemeral. It goes away unless you use it, something in your deployment to make your disk storage permanent. So if we did that, if we imagine that we had a durable file system, which of course I do on my laptop where I'm running this from, but if we imagined they were deployed that way, then let's bring up the diagram again. When you're requesting it, when you're handling this requested event and you go and fetch the file, you could just write it to that local file system. So when you crash on the expected version error and spring back to life, you'll hit this requested event again, go to handle it, and be like, oh, look, the file's already there. So let's go ahead and just not fetch it because we already have it. So that was one option that we could do. I still don't like we're crashing on the expected version all the time. So another solution was, we typically do all this writing with an expected version to protect against concurrency problems. If you let me pull up a simpler example. So I'll go to the eventide code here. Oh, look at that. I happen to have the handler right open here right now. Um, actually, no, sorry, this isn't here. Right up here, this will work. So this is in the eventide component. Sorry, the eventide component, the eventide projects account component example. And let me drop a link to that in the chat real quick, because these are really good to work through. If you're not guided in it, it can take a while. And it's really easy, totally not speaking from experience, to make a bunch of assumptions about them and then be wrong. I might have done that once or twice on my journey, but let me just drop that in here. I'm not logged into Twitch, so it won't let me. Sorry. I haven't streamed in like 2 weeks. Your browser is not currently supported. What? Used to be. No, that's not right. Let me try this again. Okay, there we go. Now it locked me in. Don't know what that was about. Whatever, we're back. So... okay, that's not it. Sorry, I'm trying to post this link to the account component example. We'll get there. Okay, copying the URL and now putting it into the chat. There, that's where you can look at this code that's up on my screen right now. Anyway, so what I was saying about all this expected version stuff, when we get the close command, we project we fetch the particular account that we're working on from the message store, from the entity store, which is runtime framework stuff. We get the current state of the account, right? And as part of that, we get the version that the stream is currently at. That version comes from the, oops, I don't want to use Brave. Let's use Opera message DB. Let's go to that real fast. Database, and where'd you go? Tables, here we are. There is this position column, and whatever the max value of that is the version that the stream is currently at. If there are no messages in that stream, which just means that there are no rows with a particular stream name value for the stream name column. If there are none, then the version is -1. But so yeah, we get that. And the reason we do that is because something I stress a lot when we're working through this stuff, and anyone who's talking about distributed computing ought to be stressing this a lot, is making sure that your various pieces are idempotent, meaning that they don't do the same work twice. So imagine, say, the $10 million bank transfer, or wire transfer is what I always like to think of. You have a component that does wire transfers, and it's not idempotent, and you will see the same message more than once. We just expect that in a messaging-based system. It does the $10 million wire transfer twice, transferring $10 or $20 million. Not very good for your staying out of jail prospects or your employment prospects. So we are going to be idempotent, and idempotent, the way we work that in these components is we're handling a close the account command. An account can only be closed once. So when we get it, we project the account. We check to see if the account has already been closed. If it has, we say, oh, cool, we've already done this one. Let's move on. However, that will not protect you against concurrency issues. So if you had two instances of this component running, handling the same messages, which is typically not what we do when we scale these horizontally. We don't want components handling these same messages. And there's in the eventide consumer stuff, you can see the consumer group information. Not going to rabbit hole that right now. But suppose somehow you accidentally, or in a few rare cases intentionally, got two instances of the same component running. Imagine that they're both running kind of in lockstep with one another. They both hit this handler because they're both handling the same message. They project the account. They both check, has this one been closed? Well, no, because no one's written a closed event to the stream, so this hasn't been closed. And so then both instances fall down to the right and would write their closed event. And of course, the drawback to that is which one's correct. And it doesn't look good to regulators to see multiple closings of the same account. So that's what the expected version is for. So in that scenario we just described, yes, they're both going right down the list together. They both hit right here. They both get the same version for the stream, which I don't know, let's say it's 10. And they flow all the way down to here. They both go to write with an expected version of 10. Well, those writes are serialized within a given category, and I can actually show you that right in MessageDB. So if we go to the write message function, which is right here, you'll notice, if I could scroll less erratically, there is this acquire lock call that we do based on the stream name. If we go look at what that function does, you can see here that it extracts the category from the stream name. So that's everything to the left of the first dash, makes a hash, it hashes it to get a number, and then uses Postgres's built-in advisory locks on that hash. And so every stream in the same category, or every message in the same category gets written in a serial fashion. So yes, you've got your two instances that send their write requests at roughly the same time, but one of them is going to go first, and that will cause the version of the stream to increment by 1. And so when the second one tries to write with the old expected version number, it gets the error and then crashes, and that's okay. Let them crash, they'll restart. It's just fine. What got us on that rabbit hole? Just describing the issue that we have here. So that's what's happening is this one. Right. So it's this consumer projects the event stream, gets a particular expected version value. This takes a long time to actually go fetch the video. And in that time, requests for the same video could come in, which add an event to the stream, which means that the expected version, this one expected, is too small now. It's no longer accurate. Component crashes. We've wasted the fetch, etc., etc. So, yes, the call stack is unwinding in my mind here. We were talking about just ignoring that. So if we didn't use the expected version option, we wouldn't have concurrency protection. We would have some duplicate messages if we ever ran two instances on the same workload. Maybe that's not terrible. I don't like it. It offends my sensibilities for sure. That's a design smell to me. Not necessarily wrong, but definitely needs some additional scrutiny. I'm not reaching for that one first. And then I was wondering if there was something we could do in the command handler. Because what the command handler meaning for these retrieve commands that we get. Because our problem is that I actually have funds transfer here. So this is the eventide account component. That example that we just looked at is often used in conjunction with the funds transfer component because a whole lot of wonderful things are illustrated. Incidentally, I can do all the shameless plugs I want on my own stream, but on December 20, there was this reader question about can one command lead to two events? And so going through over a course of many days, walking through how funds transfer and account component interact with one another. Short answer, yes, one command can absolutely lead to more than one event. But let's come back to the diagram here. This is another situation where, oh my goodness, there we go. I do know how to operate a computer. I promise I didn't forget that entirely over the break. So the command handler for funds transfer up here receives these funds or these transfer commands and writes an initiated. So you have this consumer writing to the event streams, and then the funds transfer component has a consumer on its own event. So there's also a consumer here that also writes to the same streams. But the difference here is that in a funds transfer, the command consumer only writes to the stream one time and at the very beginning. Whereas in the in our example here, the command handler for these retrieves could write 1,000 times to the same stream to note that the thing had been requested. So that's what's different here. That's why funds transfer component doesn't have the same issue. And as I think through it here, the background process is in my mind while my mouth keeps rattling on. I'm really starting to think that this might be the best solution here. But no, I want to explore more this other one. So I really wish I remembered where I had written these notes down. It might have been right here in the code. So let's go back here and okay, so let's see, such software, practical microservices, and this is the, nope, it wouldn't be there. It would be do expensive things once, composite component. It would get status on that. Okay, nothing different there. Maybe it was in this component. Ooh, yeah, there's some changes here. This must be where I took those notes. Yes, okay, so that is in device video component handlers event. All right, let's go to that one, which is open over here on the right in my Vim window. So somewhere in here, yeah, here's where it was. So this is kind of what we were musing about on the 20th. So is playing with the stream names. So when you hook up a consumer in Eventide, and I don't think that notion would be limited to Eventide. A component, a consumer, subscriber, whatever you want to call it, we call them consumers in Eventide, should only be consuming a single category, except in the rarest of circumstances. And the only one I've seen is, I was working, I haven't released it yet, have this side project called the Stream Explorer. It is not Dora the Stream Explorer, because that would get me in trouble with Nickelodeon, which would be flattering if they even noticed me, but it's just the Stream Explorer. And it consumes every message and does things like, what are all the categories that are in there? What's the current state of all of your positions for all of your consumers? Just a diagnostic thing that was inspired by one of the chapters in the book Practical Microservices, where we talked about debugging components. Anyway, right. So going back to when we do a consumer, sorry, let me finish a thought before starting a new one. Single piece flow in thoughts is certainly more helpful when you're talking to other people, I think. So let's see here. Here is where we start, say, the consumer for the device video stream category. This is where, going back to the event model, this one, it's this whole stream right here is the device video category. And when you subscribe to a category to consume it, you give just the category. And what you get is, as the consumer, is you see every message in the category in the order they were written to the message store based on the global position. So we can go back and look at MessageDB real quick. To the tables directory. There's only one table in MessageDB. Who knows? Maybe one day there will be another one. There is this global position column, which happens to be the primary key of the table, and it is a sequence, big serial sequence. That number can get quite large. So when you set up your consumer on a given category, you see every message in that category ordered by the global position. These two stream name templates aren't any fancy construct. I wrote these two strings as stand-ins for what the stream names look like, are in the same category. right? They have different identifiers. So typically when we're thinking of working with entities, we're thinking of all of their events being in the same stream. But if we come back to the event model here, event model, I don't follow all the conventions that event modeling has, but it's a useful pattern language. Anyway, some of these events store state of requests, and some of them store the state of having retrieved them. So like we have all these requested events, and then we have the fetch, which is the marker. We have actually got this from the device and put it into permanent storage somewhere. Permanent storage. This were a real solution, and we might be using something like S3 to store these. And so the fetch handler would fetch it and then also push it up to S3 before writing this event. So yeah, you could fail in the between any of those operations and have to repeat them, but for the most part, it'll work properly. And then we have the retrieved messages, which are, yes, we've sent them. So the theory is that we could actually put the expensive operation, maybe these would stay up here. I don't know. We're exploring it. This is literally what today's purpose is. And this talk through serves two purposes. One, you're new here and don't know what the heck it is we're talking about, trying to bring you up to speed. But then also, the last time I looked at this was in December. And so I don't remember. Is there a way to... I don't want a new breakpoint. There we go. Okay. If we put the slower operation in a separate stream down here, let's pull this down. And of course, the text for the stream names is way too far over here. So let me grab this and bring it back here. I'll put it right there. I guess this one would be down here, and then up here's where we would have the new one. Every diagramming program uses its own combination of keys to drag and copy. So request. Now I need to zoom in on that so anyone can see that. So what we're saying is if we put all of these events in a separate stream, but within the same category, for this to function correctly, the consumer has to get these events in the correct order. And even if we do this switch up here, remember the category is everything to the left of the first dash. So we'll still be in the same category. As I think through this, I think the retrieves we would also want, because what we want is the outside world, this command handler that can write to our event stream at any time. It is writing to a different stream than the thing that is fetching the videos. Wow, that is... Why? Why do it that way? That doesn't make sense. Remove waypoint. Why won't it remove that waypoint? Obnoxious. Let's separate that. Okay, well, you know what? I'm no longer too cheap to pay for a Lucid chart, so I'm going to not today, not on the stream here, transfer this over to Lucid chart because I'm able to work with it a lot better. Anyway, what we're trying to do is oh my goodness. Separate where the command handler here is writing to from where our event handler is writing to. Why does dragging that make new waypoints? What happens if I do clear waypoints? That's better. Bring that down a little bit more because hopefully that'll. Dear goodness. Clear waypoints. There we go. Bring you down here. And then. Okay, forget the arrows. I'm not fiddling with these anymore. Because I'm just going to transfer this over anyway. Why invest any more time in this particular diagram? This command handler can now write requested events to its heart's content. And from the categories perspective, they'll still appear in the correct order. But what that means now, though, is that when we go to fetch this, fetches and the retrieves will only happen down in this stream. Now, well, why not just make this explicitly a different stream? The trouble is that consumers operate on their own cadence. And so, what am I trying to say? So if we have a consumer consuming these requested events, if these were separate categories entirely, that consumer would come along and grab this and start processing it. And actually, there may not be a problem. Maybe it should be a separate category here. All the requests go into there. And then you might be able to change the logic here. Hang on a sec. Okay, so current thinking is the way that this works. Right, let's zoom out a little bit. Let's make this browser window bigger. Not that big. That's what we have this streaming here for. Where is... Okay, so this is for a workflow where we've previously fetched the video in question. So build goes to initiated. This is up in the composite component. Initiated sends its retrieve command. This handler when this is being handled, we can look at this in the code. Or you have caps lock on in Vim, you will do amazing things. All right, let's open our command handler here. And when we get a retrieve command, we're first going to check to see if the video has been fetched. And if it has been fetched, we fall into this one where we just say, oh, hey, cool, it's already been retrieved. Let us put that in the message store for you. If it has not been fetched, then we write a requested event. Oh, it looks like we started working on this actually. Because there's that additional plus requests on there. Okay, just getting back to speed here. So then we're going to say, okay, let's make a requested event and put that in the message store. So initiated can lead directly to a retrieve command. I'm sorry. Retrieve can lead directly to a retrieved event. So if these requests were all in their own category, the thing consuming these that would be writing the fetch could still have the command handler writing retrieved, which would give us the same problem. The trouble is that this command handler can write requested and retrieved events at any time. And maybe that's the wrong way to look at it. Maybe what this is saying is we need another stream in here that we put the requests into. And it wouldn't be a reservation stream that we've talked about before. So the brief recap of that, I wish I had need to do a good video walkthrough of this that I can link to. The idea with the reservation pattern is we want to turn several different messages that all reference the same deposit ID. So suppose your caller doesn't have any confidence that you received the request to do this deposit. You send multiple commands with the same deposit ID. We want to make sure only one of those ever gets written. So this isn't a reservation stream. In our situation here, this is a legit second request because it's coming from a different composite video. So like this one segment of time could be included in different composite videos, and that's fine. So we would need these multiple requested events to show up. That's what we expect to see. So if they just went into a separate consumer, that consumer's job is just to fetch the video. If it has been fetched, then it projects this stream. It's this different cadence thing. So, all right, let's talk through what I'm thinking here. Different consumer handles this, and that leads to the fetched event. It's a different consumer. Then this consumer would be looking for the fetched event, and its job is to take all of the pending requests and write retrieved events from that. But at some point it will project this stream and additional things will be written here. And it would have no trigger to go back and do this. So it's in handling the requested event that we have to do the retrieve check. But if this consumer is the one writing the fetched, I think this will work. And it won't be that sketch. Like, we don't have to do this weird requests thing here. There just wouldn't be a consumer down on this. So we don't need to consume these. We just need to project them. I think this is a better design. I kind of like the way this is going, actually. So if we had device video requests. Oh, do I want to go changing this? Yeah, I can put it back. It's not that hard. Yeah. Okay. So the way this flow would work then is the retrieve command comes in. This is still going to project the device video stream. And yeah, this would be a plural stream. Okay, so retrieve command comes in. We project the device video stream to see if it has been fetched. If it hasn't, we write a requested event. And yes, it might be getting fetched at the present time, but if it hasn't been fetched, we're not ready to move on. Then we have a consumer on here that sees the requested and says, oh, let me project. Has it been fetched? No. Okay, I am going to look for the fetched event. Sorry, I'm handling the requested. I go to project. Has it been fetched? No, okay, I need to fetch it. Cool, I write it. Consumer moves on to this one. Yeah, I think what this design ends up requiring is that we always write a requested event, whereas before we were saying we could short circuit that. But it still has to be in separate streams so that the command handler isn't able, because this is the thing getting projected. This is the thing that we're getting the expected version on. If something can change that while this long running bit is happening, then that's where we get into our trouble. And so what we're saying is that the command handler is not allowed to write to this stream. We always queue up the requests as a requested event. Then this consumer is coming through. The requests are now being written separate from the rest of the state here. So it's basically the same solution we had before, only instead of doing some wonky thing with an extra segment in the compound identifier. By the way, that's what's going on here. Everything to the left of the first dash, I say the first dash because we use UIDs for these identifiers, is the category. Everything to the right of the first dash is the identifier, but you can have a compound identifier, which is what these are. It's a composite of the device ID. So like every single one of these IoT devices out in the wild has its own identifier. And then there's the start minute of the video, which also identifies the particular clip that you're after. If you change your clip length, and this all kind of goes to pot. So don't do that willy-nilly. Anyway, that entire thing is the identifier, and was originally thinking like, well, just put a request on there. That'll keep it in the same category, but with a different identifier, so we won't mess up with the expected version. So it is slightly different what we're doing here. But now we're saying we're going to have a separate category of event for the requests where we write the requested. And there's a consumer just going along these in order. And it is the only thing writing to the actual event stream, which means when this requested hits, it does the long fetch. Great. In the meantime, another request came in. A retrieve command comes in. We write our requested. Fine. That is not messing up the version of this stream. So this one finally does its fetch. Oh, wait a second. I just lost the thread of it. This one finally does its fetch. How does it know to turn these into retrieved? Because, right, there's no consumer here, right? So we're consuming this one. We write the fetched. We're still handling this. Do we write the fetched and the retrieved at the same time? Because we can atomically write to the same stream. So in the one where we haven't fetched, we're going to atomically write the fetched and the retrieved as one action. This consumer moves on to this event. When it projects this stream, now we see that the video has indeed been fetched, so it directly writes the retrieved over here. So we're adding extra messages. That's fine. And these are always the queue. So retrieveds are always written by a requested handler, which is not the case in our old design. In our old design, sometimes it was a requested that led to the fetched, and then, sorry, requested always resulted in fetch. What I'm trying to say is sometimes the command handler directly wrote the retrieve because the video had already been fetched. We can project it there and find that out. Other times, the fetched event handling that is what created the retrieve. So we're no longer going to have a consumer getting fetched or retrieved events down in this component. Obviously, the composite component will still have to consume this stream because this is the only one that it cares about. And actually, this would make a lot of this a lot simpler, because we had this weird thing over here where we would write the retrieve and then go to write the retrieve sent. We could instead just watch for the requested event. Oh, I feel like I've got to redraw the whole thing because this is so different. We've got 6 minutes left. I think this is better. That extra identifier of requests on here was kind of bothering me. It just didn't seem right. Okay. I think this will work. Let's draw it out correctly. Let me go open a new document in Lucidchart. So let's see, new Lucidchart, blank document. And then we'll come back to the coding here. It's funny, reaching for that button, you get a Stream Deck and then you put it in an inaccessible place on your desk, and that doesn't make a lot of sense. But it's what I did. But in so doing, like, my face got really close to the microphone and I was like, oh, that's going to be a terrible view, but the camera's not here, the camera's up there. Oh, you know, sometimes there are things that are best left unsaid. Let's just grab those two right there. And you know what, just out of curiosity, what happens if you paste from... Oh, I guess you can't. I guess you can't. Wait a second. If I hit Control A, what happens? Grab that. Let's try it again. Okay, yeah, it won't let me paste that in. That's unfortunate. What if I do a smaller section of it? Disappointing, because things from different programs should just work together. Wow, that was so not. Okay, that's not going to work. Let's just get these two in here from the account component example. Whoa, that's really cool. Is this one messed up? Oh, I see. It's just a rendering. That is so weird. I don't want any of that text anyway. Forget what all of the fields in here are. In here. So let's come in and grab all of that text. Surely text will paste just fine. But I'm not a fan of how most things try to match the destination style. Sorry, match the source style when you're pasting. I don't think I have ever wanted that. And of course, all software must be built to satisfy my whims. Otherwise, it was done incorrectly. All right, there we go. We have those two events there. And this is looking fine. All right, this can be our flow. So let's see, that's going to result. Okay, so Draw.io, it's control click to make a copy. In Lucid, that counts as a right click because that's what control left click on a Mac is. So Lucid wins the points there. So if I want to make a copy in Lucid, it is alt click and drag. So let's grab this retrieve command here. The good news is with all this restructuring, when we get to coding it, it won't be like the worst thing ever. Because like it's still all the same. Still all the same code. Oh, interesting. So it bolded everything because that top build word there was in bold. All right, there we go. So now we've got a retrieve event, and I'm really looking forward to having all this copied over. I bet you are too. Normally I like to do this part off the stream, but need it before we can do any coding. I use that word liberally there. I'm not going to proceed without it because the visual representation is very helpful to me. All right, so we've got requested. We would also need a fetched. And I guess this would be the costly operations. And make a copy of you. When you're doing diagrams, do you talk to yourself this much too? That's the great thing about... why are you different sizes? When you're not doing a stream and you spend a lot of time talking to yourself, then people think something's wrong. But if you just turn on a camera, log into Twitch, suddenly talking to yourself while you work is really cool. It's content creation, not something else. Why 993E? I'm sure that's some sort of a text code for something. All right, cool. Got all the messages on there. Off camera, I'm going to rearrange these back into the model that we just talked about. I like the direction that came from that, honestly. I think that'll work. There's no weird thing going on about it. That's great. And that means that we'll have something to talk about at the meetup, which has been, it'll be 3 months running of this particular example. But the subtlety of the error that we were getting is very worth sharing and bringing up more. So anyway, hey, thanks for coming today. We're going to call it a wrap. We're 1 minute over. Happy 2023 to you. Wishing you all the best. And until next time, happy coding.